All right, nerds and nerdsettes. We're going to balance this equation here. I can't, there we go, that direction. Okay. And Ari did it. Okay. So here, ooh, in the very bottom, we have zinc. And I added hydrochloric acid to this. Okay. There's 3 different numbers on here. The first one says 6. That is 6 molarity. Okay, meaning it's much stronger. There's a much higher concentration of hydrochloric acid in here. The rest, for the most part, is water. You can see a lot more bubbles. The next one over is 3 molarity. The last one's 2 molarity. Okay, and as you can tell, we have a reaction. First test tube's going crazy. Second tube's a little bit crazy. And third test tube's hardly anything at all. Very top, we can also kind of see how much hydrogen gas we're making. Okay, so let's take a look and see what we're doing up, right there. Okay, so we have zinc, okay, element by itself, meaning there's no little tiny numbers. Also, we know that because it's a metal. This is a solid. Over here, we have hydrochloric acid, okay, strong stuff. Got to wear gloves, need goggles on, okay, and hydrogen has a charge of +1. Chlorine has a charge of -1. We crisscross. That's our formula for hydrochloric acid. Over here, we have zinc and chlorine. Okay, I need to look at charges. Zinc has a charge of +2. Chlorine has a charge of -1. So I need to crisscross those. I need 1 zinc. I need 2 chlorines. That's my formula for zinc chloride. That's what we're currently making in our test tube. I can't add a 3 here. I can't make a 4. I can't put parentheses around it. It's always this. Last thing we're producing is hydrogen gas. Okay, it's one of our 7 diatomic molecules. Okay, actually, let's write this on here. We got zinc chloride and hydrogen gas. A little G here for gas, and over here, this is going to end up being a liquid. Oh, and this is also a liquid. Okay, so there's our formula. Now that all of these are correct, now we go back and we balance it. Okay, there's our arrow. That distinguishes our reactants versus our products. Okay, so over here, let's start with zinc. 1 zinc, 1 zinc. 1 hydrogen, 2 hydrogens. Large 2, this is our coefficient, okay? Gets distributed to everything right behind it. We now have 2 hydrogens here, 2 chlorines. Over here, we have 2 chlorines, 2 chlorines, 2 hydrogens, 2 hydrogens. This is now a balanced chemical equation, okay? What else we need to know about this is types, okay? Zinc is all by itself. Hydrogen and chloride is a ionic compound, a positive charge and a negative charge. Okay? All of a sudden, zinc thinks he's way better and comes in and steals hydrogen's girlfriend. Zinc and chlorine are now together. The reason why? Zinc has a higher electronegativity. Okay? It's more likely to steal those electrons. And hydrogen is now all by them lonesome. Okay? Hydrogen's all by themselves. Meaning zinc came in, and hydrogen's all by themselves now. This is a single replacement reaction, okay? And now we're ready for explosion, okay? Hydrogen gas is flammable. So we want to test to make sure this reaction actually took place, and that's what's in there, okay? So we light this. We now have fire. We have this, and time for pop. Boom. Yay! Science.